and the pipe fitted at the bottom dispenses water into cone-shaped cups. So it's just like a snow cone, right? Like a snow cone cup. The cone-shaped cups have a radius and a height of 8 centimeters. Calculate the volume of water in the cylindrical container in liters. Write your answer correct to 2 decimal places. Now, we are required to find the volume of the cylinder. Remember last day I told you volume of any container is cross-sectional area multiplied by height. If this is my cylinder and I look straight through, you will see a circle. So the volume of this glass is the cross-sectional area by the height. You all remember that?
Yeah, ma'am.
So volume is cross-sectional area by height. Cross section is a circle, so it's pi r squared each. So 22 over 7 multiplied by the radius, which is 12, over 1 by 12 over 1 multiplied by 20. Work it out and give me your answer correct to 2 decimal places. All right, let me know when you have an answer. Brianna and Charissa, any one of you have an answer?
Yeah, miss.
What do you have?
I have 9,051.43.
Yes, 51.43. So, Charissa, for getting this answer, CXC would award you 2 marks. The question is worth 3 marks. You will get the next mark for changing centimeter cube into liters. So to change centimeter cube to liters, we simply divide by 1,000. So the volume will be 9051.43 divided by 1,000, and write that answer now to 2 decimal places.
9.05.
9.05. So 9.05 liters. Here you will get 1 mark. So you see how the 3 marks are awarded?
Yeah, miss.
Let's continue. Water flows from a cylindrical container along the pipe into the cone-shaped cups at a rate of 7.8 milliliters per second. Calculate the time taken to fill one empty cone-shaped cup. Give your answer correct to the nearest second. So the first thing we need to do is to find the volume of one cone. They give you the formula. So the volume of the cone is 1/3 pi r squared h. So 1/3 multiplied by 22/7 by the radius, which is 3, and the height 8. You see the radius here, 3, and the height 8 here?
Yeah, miss.
3 squared by 8. Work out that. Josiah, good afternoon. Good afternoon, Josiah.
Afternoon.
So we started question 6 of the past papers. So in your booklet, turn to the very last paper 2, which is the January 2022, and find question 6. We are on part B. All right, so what answer did you all get here? 75.428 milliliters. Did you all get that?
Yeah, miss.
Yeah.
Right? They ask us to calculate the time taken to fill one of the empty cone-shaped cups. So the rate is given as the volume over time. How do I know that? Because it is given by milliliters over seconds. And we want to find time, so we can cross multiply. So the time is equal to the volume divided by the rate. So the volume, 75.428, divided by the rate 7.8. So divide that and see what you get. And I want it correct to the nearest second.
Maybe 10 seconds.
10 seconds. So I have 9.67. The question asks the nearest second, so it is approximately 10 seconds. Rihanna and Charissa, did you all get that?
Yeah, miss.
So part C, determine the number of empty cone-shaped cups that can be completely filled from the cylindrical container. So imagine this is my container. This is my cylindrical container. And I am going, let's imagine this is cone shape, right? So we're going back to the question here. So this is my big tank and this is my cone. I am taking the content, so I am taking the volume and I am pouring it into as many cone-shaped container as possible until all the contents of the cylinder is empty. So to find the number of cone-shaped cups, you're taking the volume of the large cylinder and you're dividing it by the capacity of the volume of the cone. And that will tell you how many cone-shaped cups you can get. So let's do that. So the number of cone-shaped cups is equal to the volume of the cylinder divided by the volume of the cone-shaped cup. So we worked out the volume of the cylinder as 9,051.43 and the volume of one cone as 75.428. So work it out and tell me how many cups we can get.
Yeah, 120 cone shaped cups.
20 cups. Did any one of you all get that to confirm Josiah's answer?
Yes, ma'am.
Yeah, miss.
So the volume or the measurement question, it may seem a little bit intimidated because from the time students see this diagram, automatically they blank off and they feel as though they can't do it. CXC likes to bring the cylinder. Out of all the different containers or the shapes of containers CXC likes to bring, they like to bring the cylinder. And volume and capacity is one of the questions like the common sense. We all know, just like when you take the can of juice or the mug of juice that mommy makes in the fridge or the bottle of juice. Remember, you're not going to drink all the juice at the same time. So you will drink a glass of juice. So literally, you are taking the contents of the juice and you are filling it in a glass. So this is the same principle. You want to know how many glasses of juice you can get with the whole mug of juice. So volume and capacity is one of the questions that we can score close, if not full marks, right? So it is one of the questions. They like to bring cylinders. So they brought a cylinder in January. So let us go through the other questions and see what type of containers they bring. But you have to read the question and all the information is there. So go to the next one, which is the July 2021. So we are on question 6. Let's see what they bring. Oh, this is a favorite as well. This rectangular based container, right? So they like to give you the value and they want you to work backwards. Is it found in your booklet?
Yeah,
Yes.
Right. I am sure that mommy plants around the house, or even if it's not mommy, the neighbor has some troughs with some items in the garden. So you all know what a trough is. Farmer Brown makes troughs to feed his farm animals using wood that is 5 centimeters thick. Let us underline 5 centimeters thick because that is taken away from our volume. That 5 centimeters is taken away from the volume of the trough. As shown in the diagram below, the troughs are rectangular based, open at the top, and have external dimensions of 300 centimeters, 190 centimeters, and 160 centimeters. Show by calculation the internal capacity of the trough is that large value. Now, don't be intimidated, right? Because you're seeing so many zeros. Here's what they have. It is rectangular base. It is open at the top, right? There is a 5 centimeters thickness going right around that makes the internal dimension smaller by 5 centimeters compared to the outside. Now, let us be realistic. That is all made up of rectangles, length by breadth, right? We need to find the internal length, the internal height, right? And the internal width. So it is like we have a box. Let me see if I could get a box to show you. Just give me a second. So this is my box, right? So the outside has an external dimension of 300, 190 by 160. But the inside of the box, the dimensions are different because in my box, there is a thickness. So which means the internal dimensions is smaller than the outside. Just like if you take a piece of wood and you have to make a box, the outside is going to be larger than the inside because you have to take into consideration the thickness of the walls. The thickness of the walls is 5 centimeters. Now, we need to find volume, right? So this is a rectangular base. We know volume, cross-sectional area by height. What is the cross-section? Well, the cross-section is a rectangle. So it is length by width by height. So the volume is length by width by height. Now, we need to find the length. The length is actually 300 centimeters. But the internal length, remember the length here is 300 centimeters. So if we had to write the internal length, we will have to take away 5 centimeters, right? So this is the length here. There's a 5 centimeter thickness on this side. And there's a length on this side. So this length here will be less by 5 centimeters on this side and 5 centimeters on this side. So the length will be 300 minus 5 plus 5 because it's 5 centimeters thick on both sides. You understand that?
Yeah, miss.
So what would be the actual length?
290.
290. So we go in again for the width now. The width is 190. So this is the width here. So this is the short side, which is 190, but it is thick here 5 centimeters, and on this side is thick here 5 centimeters. So again, we will take the 190 and subtract 5 plus 5. How much is that?
180.
180. Now, the height. What they had said in the question is that it is open at the top. So you see this few lines, which is introduced in the question with Farmer Brown, that has a lot of information. It tells you the thickness of the material. It tells you that it is open at the top. So if it is open at the top, the height here is really only 5 centimeters shorter because the top here is open. So there's no need to minus another 5 because the height here is 160 and it is 5 cm smaller inside the box. We would have subtracted 5 cm again, like what we did for the other two measurements, but they said the rectangular base trough is open at the top. So the height will be 160 minus 5, which is 155. So work out the volume and see if you get that large value. 290 by 180 by 155. Let's see if you get that 8 million.
Yes.
So you get 8,091,000 centimeter cube. And this is worth 3 marks. So for 3 marks, you were expected to do this and expected to get the calculation. And this wasn't too bad. So sometimes you write QED at the end, and that means it was quite easily done. So take down whatever you need and let's continue. So tomorrow, in tomorrow's class, we will be starting statistics, right? So tomorrow we will start statistics. So that will leave us with 4 questions remaining, which is the sequence. I will teach you everything that you need to know how to work on the sequence. So that sequence, we are getting full marks in that. I want to spend some time in question 8, 9, and 10. That is the circle theorems, the vectors and matrices, the bearings, the trigonometry. I will teach you everything that you need to learn in circle theorem, so we will get that. That is normally coupled with geometry, which is the trigonometry or the bearings, right? And I will teach you everything that you will need to learn on vectors and matrices. So questions 7, 8, 9, and 10, we are aiming for at least 7 or 8 marks per question, right? So that is the questions that are worth a little bit more marks in the paper, and we want to spend a little more time on those questions, and we are going throughout the vacation. The date and the time, I will have to let you know. Calculate the volume of wood needed to make the trough. Well, that's simple. They don't want the internal capacity. No, they are asking you for the external capacity. So for us to find the volume of wood needed, it will be 300 by 190 by 160. So take it down and work it out. 300 by 190 by 160. So the volume, length by breadth by height, 300 by 190 by 160. So work out that, and that is the first part.
Will be 9,120,000.
9,120,000. Now, right. So the question is worth 3 marks. I have the volume of wood needed to make the box. So listen, this is my box. It is hollow. So which means that if I have the external volume and I have the internal volume and I subtract it, that should give me the volume of wood. Because remember, the box is hollow here. So I don't need any wood really to fill the whole box. So once I subtract the external from the internal, that will give us the volume of wood needed. So the volume, this is the volume of the external. So the volume of wood needed would be the volume of the external minus the volume of the internal. So you're taking the 9 million and you're subtracting the 8 million and something. How much was it? 8 million and 8,091,000. See what you get.
1,029,000.
1,029,000. Right? Did Charissa or Rihanna, any one of you all got that?
Yes.
Yeah.
Okay. Now, Farmer Brown must paint the internal surface. So he painted inside the box. Given that 1 gallon of paint covers approximately 280,000 of surface, determine the total number of paint in liters needed to paint the internal surface of the trough. Now, this is what we call total surface area. And when you all, if mommy or daddy decide to change the color in your room, right, based on the area of the walls, you can work out before you go to the paint shop the number of gallons of paint required. So this is Farmer Brown's trough. Remember, it is open to the top. So there is no need for Farmer Brown to paint the top. There is no top. So he has the bottom, the rectangular bottom. He has the 2 long sides and he has the 2 short sides. How many faces is that?
4.
4 faces. So let me count again.
5.
5. So the big part in the bottom here, the 2 short and the 2 long. So let's work out the total surface area. So we're going back. So we have the internal part here. So if we're looking at the long side here and this side here, that is this big part at the bottom here, right? So we have to subtract, so it will be, how much was it? 290 here by this length was 180. So the area of one face is really 290 by 180. So that is the big part at the bottom here, right? How much is that? $290 by 180. $290 by 180. How much is it?
52,200.
Now, there's no need for us to multiply that by 2 because the top of Farmer Brown's trough is open. So he only painted in the back here. So let us work out the area of the 2 short sides. So the area of the 2 short sides would be the width would be 180 by 155 here. So multiply 180 by 155. And we'll multiply that by 2 because there's 2 short sides. $180 by 155 by 2. How much is that?
55,800.
55,800. So we have this area, we multiply by 2. We have the area in the back, right? So we can work out the area of the 2 long sides now. So it's 290 by 155 now. So it is 2 by 155 by 290. 155 by 290 by 2.
$89,900.
89,900. Work out for me the total surface area. 89,900 plus 52,200 plus 55,800.
$197,900.
100, oh, 900. 900, right. So that is the total surface that Farmer Brown wants to cover. So we want to know how much paint is needed. So this is the area that he wants to paint. 197,900 cm squared. So the area is 197,900 centimeters squared. 1 gallon of paint covers 280,000 of surface. Determine the total number of paint. So to find the number of liters, we will divide 197 over 280,000 multiplied by 3.79. And that will give us how many paint he needs. 197 divided by 280,000 multiplied by 3.79.
Um, 27 liters.
27, check it back to side.
Well, 26.7.
No, I get 2.67 liters. Check that back.
Means I got 26 points.
Did I put that extra zero? Oh yes, I put an extra zero here, sorry. So it's 197,900 divided by 280, right? Multiplied by 3.79. Yeah, work it back. Sorry, I put an extra zero. Look the answer here. So how much liters would Farmer Brown have to buy?
That's like a 2.6 liters.
Now, do they sell half liter of paint? How much liters he will have to buy?
3.
3. Because they don't sell half of a liter or they don't sell 0.6 liters. If he buys 2 liters, he would not have enough paint to paint the entire trough. So Farmer Brown will have to buy 3 liters. Do you all understand that?
Yeah, man.
All right. Now, when we come back, we'll take a little break. When we come back, tell me something with the multiple choice. How far did we reach? Were we on questions 11 to 20?
No, miss.
We still doing 1 to 10?
Yeah, miss.
All right. How far did we reach in the 1 to 10? Did we go all the way up to 2021?
No, miss, we will be starting May, June 2019.
Okay,
Yeah.
May 2019. All right. Well, what I will do, when we come back, we will try to do 2 or 1 question and we'll do some multiple choice. So this was the July 2021. I am giving you a break for 10 minutes. When you come back, we will do the January 2021. All right? right? Have you all written?
Yes, ma'am.
All right. In this question, we have to take pi as 22/7. So if they give you a value for pi, try and use it and don't use the 3.142, right? The diagram below shows a rectangular tank with base 50 centimeters by 40 centimeters by 15, right? The tank is filled with water to a depth of 15 centimeters. So we're going to do an experiment here this afternoon, right? We have a container that is rectangular, just like what they have there. So this is my rectangular container. I have filled it with some water, and you see that the container is not filled, but there is a depth of water in the container. Are you all seeing that?
Yeah, ma'am.
So it is measuring 15 centimeters by 50 centimeters by 40. So the volume of water in the tank, right? Now, if this is my rectangular tank, how am I going to find the volume? What is the volume of this rectangular tank that is in the form of a cuboid? Hello? All right, sorry about that, right? So I was asking, this is my rectangular tank. How am I going to find the volume of this tank? Do you all have any idea?
Length by width by height.
Right? Length by width by height. Do you know all of the dimensions?
Yeah, ma'am.
So find for me the volume. Length by width by height.
30,000.
30,000. Who could confirm that?
Me, ma'am.
What is the units?
Centimeters cube.
Centimeter cube. Now the units is important, right? It is worth 2 marks. So when you multiply that and you put the correct answer, you'll get your 2 marks. So this wasn't bad at all. So I have my cylinder and I have my rectangular tank here. So this is used to fetch more water to pour it inside here, right? The cylindrical container is used to fetch more water to fill the rectangular container. The container, which is completely filled with water, has a radius of 20 centimeters and a height of 21. So all the water in the container is added to the rectangular tank. Calculate the total volume. So here what? It is like you are taking this container or this glass full of water you are filling it and you are pouring it into the rectangular tank. Would you expect the volume to increase or decrease?
Increase.
So the water level will get higher, not so?
Yeah.
Right. So I tell you again, CXC likes to bring the cylinder. They like to bring the cylinder. So volume of a cylinder is cross-sectional area by height. The cross-section is a circle, so it is pi r squared each. So work on that for me. They told you in the question to use pi as 22/7, so we're going to use that.
Must I get 26,400 cm cube?
Centimeter cube. Who can confirm that?
Yes,
All right. So that was the capacity of the container here. But remember, in my rectangular tank, I already have volume that was 30,000. So if I pour this, you now tell me that you expect the water level to increase. So you're adding 26,400 cm cube to the 30,000. So the total volume is the 30,000 that was already in the container plus the 26,400.
56,400.
56,400 centimeter cube. Right? That wasn't too bad. Do you all understand so far?
Yeah.
yes,
Yes.
Right. We're going back to the container now. My water level has increased. So therefore, the rectangular container has a new depth because I have increased the volume by 26,400. So we want to show the new depth of water is 28.2. Remember the new depth of water in the rectangular tank. So the volume in the rectangular tank is 56,400. The length and the width will stay the same, but the height will change. So the length and the width is 40 by 50. So 40 by 50 by sum h will give me 56,400. Work out h.
$28.2.
28.2. Who could confirm that?
Me, miss.
yes, miss.
So that one wasn't too bad. We're going again. So they are telling you the vertical height. That is when the rectangular tank is completely filled. Has a height of 48 centimeters. Right now, the height is 28.2. The actual height of the filled tank is 48. Right now, it is 28.2. We want to know how many more of this is needed to fill this so that the height reaches 48. So let us work out the volume of the rectangular tank with the height 48. So the volume of the filled tank, length by width by height, 50 by 40 by 48.
$96,000.
96,000. Tell me something. That 96,000 was an empty tank. But I have 56,400. So it means that the difference, the empty space from the pink liquid to the top is what I have to fill. So the volume required to fill is 96,000 minus 56,400.
39,600 cm.
9,600 centimeter cube. But one cylinder has a capacity of 26,400. So the number of cylinders required will be 39,600 divided by 26,400.
$1.5.
1.5. So this question wasn't too bad, right? All the information was given and we are accustomed with this sometimes. All right, good afternoon and welcome. We are on to question 6 of the CSEC Mathematics paper 2. CXC has identified they are bringing questions involving perimeter area, volume, surface area of 2-dimensional and 3-dimensional shapes. So we are going to focus on those areas. They have not brought surface area in quite a while. So I went to the past papers and I tried to pull the questions that are relevant. So those are the questions that we will be looking at this afternoon. So let us begin. Water is poured into a cylindrical bucket with a base area of 300 centimeters squared. If 4.8 liters of water is poured into the bucket, what is the height of the bucket? So we are going to assume that this glass is my cylindrical bucket. The base area, it is a circle. Are you all seeing that?
Yeah, miss.
Right. So volume is base area by height. So that is the first thing we're going to write. Volume is the base area by the height. So the base area is a circle. They gave us the area of the circle. So there's no need to work out anything there. So if I were to take my bottle and this bottle contains 4.8 liters, the question they are asking you is what is the height of the water in the bucket? So imagine you're pouring the liters in the cylindrical bucket. They are asking you to find the height. So sometimes it helps with a diagram. So this is a cylinder. Notice the cross section. So let me see if I could. Right. So this is my cylinder and this is my volume here. They are asking you to find the height. They are telling you that the base area is 300 centimeters squared. Now, they gave you the volume, but they gave you the volume in liters. Now, if we look at the marking scheme for this question, it is a 3-mark question. So that means that although they gave you some information, you still have to do some working. So 1 liter is equal to 1,000 centimeter cube. The first thing I want you to work out for me is 4.8 liters. So you multiply 4.8 by 1,000. So work out that for me first.
Good afternoon, Miss.
Good afternoon. All right. Let's go 4.8 by 1,000. What's the answer?
4,800.
4,800. So you are expected to know to change liters to centimeter cube. So now the volume is 4,800. The base area is 300 and we want to find the height. So we divide both sides by 300. So find the height for me. (4,800) divided by 300 and put your answer in centimeters.
16 centimeters.
Could anybody else confirm that? Did anybody else get 16? So let's demonstrate. This is my glass. This is my 4,800 centimeter cube. I am pouring it in the cylindrical bucket and the height is 16 centimeters. So that is what the question asks. All right, let's move on. So we have what we call a cuboid, and the cuboid is made up of rectangles, 6 rectangles in particular. So it's just like a box here, right? This is my cuboid. State in terms of H, the area of the shaded face of the cuboid. The shaded face is a rectangle. The width is 4, the height is H. Find for me the area. It is a rectangle. So area of a rectangle, L by W. Work it out. And you will get your answer in terms of H. That is fine because we have not worked out the value of H. And they did tell you to state in terms of H. So that means that H must be part of your answer. Who has the answer? So we're looking at this face here. Here is, oh, I should turn it like this. Here is 4 and this is H. What is the area of that face? Four multiplied by H, which is 4H. Did anybody get that?
Yeah, miss.
All right. So that is the first part. Write an expression for volume. Volume is for volume for cuboid, length by breadth by height. So let's write that. Volume of a cuboid L by W by H. We have 4H. What is the length? What is the missing length that we did not use as yet? Because we used 4 and we used H. What is the missing length that we didn't use as yet?
13.
13, very good. So 13 is part of my answer. So multiply 13 by 4 and write the volume. What is 13 by 4?
52.
52H. Do you all understand so far?
Yes, miss.
Yes, miss.
So, part 3 now. If the volume is 286, calculate the height. So now they are giving you an answer for V and they want you to find the unknown H. So 286 is equal to 52H. Find H. 286 is equal to 52H. Find H. And you will get a decimal. Remember, for the measurement question, your units is important. So if it is centimeters, meters, you need to write that, okay? All right. So how do we find h?
286 over 52.
Why 52 and not an answer, like not a number like 10? What tells you, Rihanna, that is 52?
Because you're using it in terms of h.
All right. More precisely, it is a number in front of the h, right? So if the number in front of h was 5, we would have divided by 5. So, but you were correct. Thank you. So h is 5.5 centimeters. Yes?
Yes, miss.
Now, we need to get a rectangular piece of paper. So you need to go and get a rectangular piece of paper. So in the meanwhile, if you're not writing, go and get a page. It doesn't have to be this big, but it has to be a rectangle. Quickly. I have my page trying to use a color so that it shows up. Is anyone still writing? Is anyone still writing?
Yes.
Yes, Brittany, yes or no?
No, miss.
All right, so we're moving ahead. So they bring in surface area, right? So anything dealing with surface area, we're trying to touch on tonight. Now, form a cylinder. Form a cylinder with your paper. This is my cylinder. So try and go for a piece of paper. It will go a long way, especially when you have to understand what's going on here. So this is my cylinder. This was my rectangle. So I'm going to put in my dimensions. You do the same. So I want to see 12 and I want to see 8. All right, are you all seeing my paper? Can you all see the 12 and the 8? I should have written it a little bit bigger. Listen. All right. Right, you all seeing my 12 and my 8 on my paper?
Yeah, miss.
Right. Do you see that I can form a cylinder? This is my cylinder here. It has a circle here, right? Now, when I open this, it forms a rectangle, not so?
Yes, miss.
Right, now watch this. This length, that is 12 centimeters, is the diameter. That is what they gave us in the question. So we're going to underline that. The diameter is 12 centimeters. So how am I going to find the radius? If the diameter is 12 centimeters.
It'll be half of the diameter.
So the radius is the diameter divided by 2. So half of 12 is 6 centimeters. Do you all understand that?
Yes, miss.
Right. Now, we'll come back to the cylinder just now. we want to find the circumference. So the circumference is the distance around my cylinder. It is just like we have in our school, we have a field that is circular. So if I tell you to go and walk around the field, I am really telling you to go and walk around the circumference. So the circumference is the same as the perimeter. So we use perimeter for rectangles and squares, but for circles, we have a unique name for the distance around, and that is called the circumference. So the formula for circumference is pi by diameter or 2 pi r. It is 2 marks, so go ahead and work it out. They told you to use 3.14. So please don't use anything else. The question asks for a specific value for pi. You are to use what is stated in the question. So you are not to use 22/7. You are not to use 3.142. It is specific to 3.14. So that is exactly what you're going to use. So therefore, every single student writing exam is supposed to get the same answer because they have specified a value for pi. So pay attention to that, please. The answer that I have is 37.68 centimeters. Did anybody else get it?
Yeah.
All right. So remember, we can take our paper and we can form our cylinder. That's interesting, not so? I can take this rectangular paper and I can form a cylinder that has a circle in it. So this length is the circumference of the circle. You all seen it? Look. The length here, which is the 37.68, is actually the circumference of the circle. You all seeing it when I form the circle? Look, 37 point, no, it's not 12. This length that I asked you to find the circumference of the circle here is actually 37.68. Are you all seeing that?
Yeah, miss.
So we going on. They ask you to state the values of A and B. So A is actually the circumference of the circle. So A is 37.68, right? And the height of the cylinder is 8 centimeters. That is what we had originally. B is equal to 8 centimeters. Look, B here is the height. So for some of you who not seeing it, watch it again. This is my cylinder. I ask you to work out the circumference. What is the circumference? It is the distance around the circle. In part 2, we worked out the circumference as 37.68. The distance around here is 37.68. So when I open my rectangle, this is the length. Yes? They ask us to find the area of the curved surface of the cylinder. The area of the curved surface of the cylinder. So they are asking for the curved surface of the cylinder. So the total surface area of the cylinder. So the area of the curved surface is 2 pi RH. We worked out 2 pi R already as 37.68. We have the height B here as 8. So replace 2 pi R with 37.68 and multiply that by 8 and see what you get. So 37.68 multiplied by 8, I have 301.44 centimeters squared. Did you all get it?
Yes, miss.
All right, now I'm going to pour some liquid now in this cylinder. So I have my 0.5 liters and I'm going to pour it in this cylinder. Again, they are asking you to find the height. So some information that is needed. We need the volume of water that is being poured. The volume of water that is being poured. This is 0.5 liters. We need to change liters to centimeter cube. So 1 liter is 1,000 centimeter cube. So find for me how much is 0.5. The next thing we need, volume of a cylinder is the base area by height, or we have 2 pi R H. So we have the radius to be 6, and we want to find H. So how much is 0.5 multiplied by 1,000? 0.5 multiplied by 1,000.
500.
500. Now you can't work in liters. So every time they give you a volume in liters, you must change it to centimeter cube. So 500 is equal to 2 by 3.14 by the radius 6 by h. So the volume pi r squared. Just now, let me make this correction here. So here's supposed to be 2, this is supposed to be 6. So 6 by 3.14 by 6 divided by 3.14 by 6 by 6. So the volume is pi r squared h, or the base area by the height. Why I emphasizing on the base area? It is a circle. Area of a circle is pi r squared, right? And the height is what we want to find. This is the unknown. So work it out. All right, does anybody have an answer? Did anybody get an answer? 500 divided by 3.14 divided by 6 divided by 6. Did anybody get an answer for the height? This is going to cancel. 3.14 by 6 by 6. I have 4.42 centimeters. Did anybody get that?
Yes, miss.
All right. Is anyone still writing? Is anyone still writing? The diagram below, not drawn to scale, shows a field in the shape of a sector of a circle with center O and diameter 28. If they give you the diameter, how do we find the radius? The diameter, so the radius is 28 divided by 2, which is 14. Do you all agree?
Yes, miss.
So the radius starts from O. So OZ is 14 and OP is also 14. Which length do we have to work out? Which length do we have to work out? Do you know the length PZ?
No, miss.
No. So PZ is part of the perimeter. So I'll do the perimeter first and we'll come back to the area, right? So the perimeter is equal to OZ plus OP plus PZ. OZ is 14. OP is 14. We do not know PZ. So PZ is part of the sector. A sector is part of a circle. Just as a pizza slice is part of a circle, the sector works in the same way. So we need to know what is the formula for length of an arc. This is called an arc. So the formula for the length of the arc PZ is the angle, and here the angle is 90 degrees. The angle over 360 multiplied by 2 pi r. So we need to find the length of the arc. So 90 over 360 multiplied by 2. They told you here to use 22 over 7. So that's what we're going to use. 2 by 22 over 7 by 14 over 1. So take it down and work it out and see what you get. Let me know when you have an answer for PZ. Anybody with an answer for PZ?
22.
22. Could somebody confirm that it is 22?
Yes, miss.
All right. So find the perimeter now. Add 22, add 14, and 14, and see what is the perimeter. The length is actually in meters. So what is the answer in meters?
50.
50. So write down this formula somewhere and learn it. For area now, area of a sector, the angle over 360 multiplied by pi r squared. So work it out and find the area.
One 154 meters squared.
Oh, that was quick. It's 90 over 360 multiplied by 22 over 7 by 14 by 14. 90 could go into this 4 times, 7 could go into 14 2 times, 2 could go into 4 2, 2 could go into 22 11, and 11 by 14 is 154 meters squared. That is correct. Thank you. Now, you don't have to do all that cancellation. You have the use of your calculator, so you can use it, okay? All right, so take your rectangular paper that we used just now and fold it into 3 pieces, so we form a triangular prism. So fold it, make 3 folds, right? And we're going to form what we call a triangular prism. All right, is anybody still writing? All right, let's continue. So this is the triangular prism that we formed from our rectangular paper, right? Now we want to find the area of triangle ABC. Now, to find the area of a triangle, we need the base and we need the height. Here we have the base, so we need to find the height, right? So this is a right angle triangle, also known as a right triangle, and we can use Pythagoras' theorem. So this side opposite to the right angle is called the hypotenuse, and it is also called C. This is A, this is B. So C squared is equal to A squared plus B squared. C is 10. We are trying to find A. B is 6. So 10 squared minus 6 squared is equal to A squared. So work it out. A is the square root of 10 squared minus 6 squared. This is Pythagoras' theorem. All right, so take it on and work out the value of A. When you find the value of A, work out the area. So area of a triangle, base by height over 2. All right, let me know when you have an answer. I have A as 8 centimeters. Did anybody else get that?
Yes, miss.
So 8 multiplied by 6 divided by 2, area of the triangle, 24 centimeters squared. Do you all have that?
Yes, miss.
All right. Is anyone writing so far? Is anyone still writing?
No, miss.
Yeah. No. I don't have a scissors. So volume, right, is cross-sectional area by height. So if I were to look straight into my triangular prism, are you all seeing that the shape that is staring at you is a rectangle? Is a triangle, sorry?
Yes, miss.
Right. Now, if I cut it, is the cross section here still a triangle?
Yes, miss.
Right. Let me cut it again. So for this prism, the volume is the cross-sectional area. And just like a cylinder, The cross section of a cylinder is a circle. The cross section of a cuboid is a rectangle. The cross section of a triangular prism is a triangle. Let's go back. Let's go through that again. The cross section of a cylinder is a circle. If I cut this cylinder, I am going to see a circle. The cross section of this cuboid is a rectangle. If I cut it at any point, when I'm looking for the cross section, it is a rectangle. This is a triangular prism. The cross section is formed by cutting crossway here. So the cross section of this prism, no matter how many times I cut it, I will always get a triangle for the prism, right? So that is some things that we can also write. So let's write that. So we remember. All right, so volume. So let's write of volume is cross-sectional area by height. For a cylinder, it is a circle. So the cross section is pi r squared by height. For a cuboid, it is a rectangle. So it's length by width by height, right? For the cross section of a triangular prism, it is a triangle. So it's base by height over 2 by, well, in this case, there's already a variable height. So we can't put height again, so we will just put L, which is the length of the prism, right? We can't repeat height again, so we will call it L. So do you all see that this is common here? And do you see that the cross section is the shapes that we can identify?
Yes, miss.
Right. So we have the area here to be 24. So this rectangle this triangle has an area of 24. So if I cut anywhere, the area will always be 24, but I want to find the length. So I have the volume. So volume is the area by height. The area was worked out in part 1 as 24. The volume is given as 540. Work out the height or the length of the prism. Go ahead. You may want to write as well, area of a circle, pi r squared, area of a sector, angle over 360 by pi r squared. You may also want to write circumference of a circle, 2 pi r, or pi by diameter, length of an arc, angle over 360 by 2 pi r. You may also want to write if the diameter is given, diameter is equal to 2r. Right, so these are just a couple of formulas that is helpful, especially in the measurement part. So 540 divided by 24. Let me know when you have an answer.
22.5.
Yes. Who could confirm that H is 22.5?
Yes, miss.
Yeah, miss.
All right. So this is my triangular prism. Surface area is the area of each face. So it is a triangular prism. And they did identify they are bringing surface area, right? Now, surface area is if you open out the shape and you pass your hand on all the faces. Now let us count the number of faces on this, right? So I have one triangular face. I have another triangular face. Are you all seeing that?
Yes, miss.
So I have two triangular faces. I have one rectangular face and I have another rectangular face and I have another rectangular face. So I have two triangular and three rectangular faces. So how many faces do I have in my prism?
5.
5. So I have to find the area of each face to find the surface area. The prism is made up of 5 faces. So to find the surface area, I need to find the area of each face. All right, let us go back here. We're making this big here because we need to use this. Right. Here, this area is the same area here. You all agree?
Yeah, miss.
So this is 24. So this will be 24. So 2 triangular faces, 2 by 24, which is 48. So we have 2 faces already accounted for. The length here is 22.5. Remember, we have 3 rectangular faces. So what is the area of this face here? What is the length and the width? What is the length and the width? You see in that first face here, what is the length and the width? So the area of CFBE, what is the length and the width? The length is 22.5, the width is 10. Are you all seeing it? Look, you see in the face?
Yes, miss.
Right. So it is 22.5 by 10. Work it out. $22.5 by 10 is how much?
225.
So how many faces remaining? I have 2 and I have 1. So I have two faces remaining. Oh. So look at the other face here. This length here we worked out to be 8 centimeters. And this is what we call a Pythagorean triple. So take a note of this too. This is important. The Pythagorean triples are 3, 4, 5 because 3 squared plus 4 squared is 5 squared. 6, 8, 10 because 6 squared plus 8 squared is 10 squared. 5, 12, 13 because 5 squared plus 12 squared is 13 squared. So those are 3 Pythagorean triples. So without even working out anything here, you are supposed to be able to spot 6 and 10 and know here is 8. So take down this. This is important. It will help you. So this here is 8. And this length here is also 22.5. So the area of CFAB AD is 22.5 by 8. Watch it. This is our next rectangle here. And the last rectangle is the one to the bottom. So this is the one 6 by 22.5. So the area of the last rectangle, 6 by 22.5. So work out all the area of each rectangle, add it to the area of the triangle, and let me know what is the total surface area. Right, what is the total surface area?
540.
540. All right, let's see. So we have 22.5 by 8. This is 180. And 6 by 22.5. This is 135. So 48 plus 225 plus 180 plus 135. I have 588. Check it back and see which one you made an error.
Oh, yeah, miss. Sorry.
You forgot to add the 48.
Yes, miss.
All right. All right, so the diagram below, not drawn to scale, shows an open cylindrical container. Now CXC likes to bring the cylinder. So this is one of the shapes of containers that they like to bring. So you all get familiar with the cylinder, just like a glass. So a glass is in the shape of a cylinder, right? Now, they did mention that it is open at the top. It is made of uniform thickness. So just like we have a glass that is thick, because if you notice in a glass, the inside has a different radius compared to the outside, because remember, contents have to be poured inside of the glass. It has to be poured inside of the cylinder, right? So the inner and the outer radii are two different lengths, right? So this cylinder, they asked to draw a cross-sectional view, and a cross-section is like when you look downwards, just like when we did the cross-section of the triangular prism a short while ago. We did the cross-section of the cuboid, which was a rectangle. The cylinder is the same thing. So if I were to face the cross-section to you, you will see that this is a circle. More importantly, there's an inner and an outer circle, right? It is uniform thickness. So when we look at this glass and we are going to imagine that this is the cylindrical container, you are